Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. This is video number 3 in our new video series on how to utilize the binary logistic regression, and with the help of the Qwen in order to come up with a calculator that can be used to calculate the probability of something based on some given data that have been subjected to the binary logistic regression. In today's example, we're going to look at how one can utilize a kind of a past medical record to see whether a patient that is coming for a kind of a diagnosis, uh, maybe you can use that to give the patient a kind of a preliminary status of his condition. In this example, we're going to look at how we can utilize the past patient's record to see whether we can create a kind of app or maybe a calculator that can maybe tell a patient that he may likely have a kind of a kidney disease. So you see, in this part of our in Yobe State, actually, from where I came from, especially the Keshua, Jakusko, and Dukru. So they are having these kidney issues, and normally the people comes to the hospital when uh, the problem is at a kind of an advanced stage, whereby it is somehow difficult to kind of arrest the progression of the listing, because mostly they normally comes very late. So maybe if we can maybe develop something like this, or let me say if the health professionals, because it is their own field, I'm not a specialist in this particular area. So if they can utilize all the past information and maybe come up with a kind of an app that these people that are living in those parts of the state, so maybe they can use it to see the risk level of their distance so that they can come to the hospital at a very good time, so that the problem can be, or the maybe the progression of the problem can be arrested. The state government is actually trying. Uh, it is rendering a kind of a pre-dialysis for all the indigents, and at the same time, I think it is collaborating with the United Kingdom in order to find a lasting solution to the problem, which is a good thing. But however, uh, what they are doing is actually a kind of problem focused research, whereby you try to understand why is it that the problem is happening, that is to get to the root cause of the problem. So to do that, you need to, like, particularly with regard to this, a lot of factors need to be considered, like the environmental factors, the lifestyle of the people that are living in that particular area. Maybe a possible contamination could be looked into, like maybe water sources, the food they take, or maybe some medical, or maybe some medication that maybe the people used to take, or something like that. So you try to understand why, you formulate a lot of hypotheses, then you test this hypothesis, then at the same time you now come up with a possible solution that can check out the root of the problem. But this is a kind of a time consuming, and it requires a lot of point. So you see, it will take time, and the problem keep on persisting, and people are dying. So as a result of that, maybe there is something we call solution focused research. In solution focused research, you don't normally focus on this on the root cause, but rather the symptoms. So you just use the the patient's information, so that you can be able to tell whether this patient may likely have this disease, so that you can direct the patient to a kind of maybe intensive medical diagnosis, and the professional ones can now maybe give and a kind of a verdict with regards to that, and maybe of a appropriate advice to that particular patient. But however, in this one, we're going to look at maybe the effect of the H, the blood pressure, the albumin, then the creatinine, then the blood sugar, and maybe a patient is having a kidney disease. Before I proceed, let me make it clear that this is a hypothetical data. So that means I formulated the data. So these data are not taken or maybe collected from the hospital. But ideally, if these kind of things are to be done, so one needs to go to the hospital, apply for permission to use the data to collect the necessary data. Then you make sure you apply all the ethical consideration because these are people informations. So you cannot just uh, maybe mishandle it. So there should be a kind of a high level of confidentiality in handling all these things. So, and this is a call to our like all those institutions that are maybe uh, like are medically inclined, have a lot of them. So before waiting for the big outcome from those teams, so they should also looked into how they can be able to help their community to come up with a possible solution to mitigate this particular uh, issue. So I'm not a medical personnel. I'm not going to relate all of this to how they affect the or maybe influence the kidney failure or whatsoever. So all what I will say is this: maybe from the previous information of the patients, their age were collected, their blood pressure, their albumin, this thing, then the creatine level, then the blood sugar, and if the patient is either a kidney patient or not. So like for instance, the first patient with this parameter, it happens to be recorded or coded as 0. So that means this patient is not suffering from any kidney infection. Like for instance, this particular second patient, he got this information and he has been coded as 1. So as a result of that, so this means that it is a kind of this thing. So it's a kind of a kidney affected. His kidneys is been affected. So this is the information that we're going to use. So now I'll try to take this one into the SPSS. So I have already done that. So these are the information. So I'm not going to repeat the process on how to take these data to the what to the SPSS because I have done that in the earlier videos. So all what I will do, I will just go to the analysis, then locate where the regression is. Then I will try to click on the binary logistic regression. The kidney disease, which is the dichotomous data, will go to the dependent variable. So and all the edges and the rest will now go to the independent variable. So you can come to the option, select the 95% confidence interval, then continue, then you can click on OK. So let's go and see the data. So this is the table. So these are the coefficients and this is the constant. So what this means is that let me just explain the H. It has a coefficient of 0.08 and an odds ratio of 1.008. So what this means is that if the patient age increases by a year, then the odds ratio, that is the chance of the ratio of the patient to uh, maybe to likely have a kind of a kidney disease will increase by 1.008, though it is not statistically significant. So you need to also consider the p-value, so to see whether it is significant or not. So let me just copy this table and maybe take it to the Microsoft Excel. So let me just paste the table somewhere here. So let me just paste the table. Okay. So let me just paste the table. So now these are the let's say the cells for this intercept. What I just did is I just press equality, then I took the first one, then I now drag the distance, so it will give me all the remaining intercept. So now what I will do is this. I will try to calculate the probability. The formula is inserted. Like I said, is 1 all over then 1 plus exponential open bracket negative, then the model developed. So, and that will give you the distance. So let's assume, let's say we say the age of the person. Maybe this is being developed from the previous patient's record. So maybe a new patient comes to the hospital, maybe the primary health centers. So maybe uh, his age is 45, maybe his blood pressure, let's say 120, then the albumin distance, let's say 3, and the creatine level, let's say 2.1, then his blood sugar, let's just say 100. So you can now see the probability of that patient having a kind of kidney issue is 0.0 so which is very small. So here you can, in developing the simple calculator, you can maybe segregate the range by saying maybe from 0.00 to maybe 0.03. So you can now say that the patient should eat healthy, maybe from 0.03 to 0.05. You can now say that maybe the patient should immediately go to the hospital. That is maybe low risk, but go to the hospital maybe from 0.05 to 0 to 1. So you can maybe write that it is a high risk and the patient should quickly see a doctor or something like that. So at least with this, it can help all those people to try to, maybe since we have all these primary health centers, so I think it's not a difficult thing to run this particular test. They are very simple. The blood sugar, the creatine, and the album, and the rest, the blood pressure. So I think they can, maybe in all of these primary health centers. So if all these things could be provided, then the patients or the people living there will now be going there and be having all these variables checked, and maybe they can be using all these applications to see the risks they are in so that they can quickly go to the hospital. So it's not like solving the problem, but utilizing the symptoms to come up with something that can help in terms of, well, maybe in a form of awareness or something like that, or to keep the people on alert regarding that particular thing. So let me go to the Qwen. So let me go to the new chart. So what I will do, I will start by writing. Let's say this is a what? This is a model uh, developed. Let's say developed. Let me just make this one to be the normal distance. So let's say this is a model. Let's say developed from, let's say, binary logistic regression. So I need to write the model. So let me just quickly this thing. So let me the constant is what? Minus 0.434. So I cannot say minus 0.434. Then what is the first variable, which is the that is the h, and it has a coefficient of 0.00h. So I can now say plus, let's say 0.00h to be multiplied by what? By the age of the patient, then minus 0.00h to be multiplied by what? By the, let me see, what is the next? That's the blood pressure of the patient. So let's say blood pressure, then the other one. So you take this, the next is what? Is minus 0.486 minus 0.486 to be multiplied by the albumin, then what again. Let's check the other variable, which is what. This is, I think, 0.001, something like that. So it's very negligible. So let me just use like okay, let's say plus 0.00, let's say 0.01 multiplied by creatinine. Is it creatinine? And what is the last one? It is plus 0.016 times the blood sugar plus 0.016 multiplied by the uh, blood 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 sugar. So we said this is a model developed from binary logistic regression. So we have written the model. So maybe you can state the reason of the model. So let's say to maybe calculate the what, the probability. Okay, maybe let's say patient having a kind of having a, let's say kidney what disease. So I can now say create a calculator, let's say create a calculator to predict or to calculate the probability let's say of a patient, let's say having let's say kidney, let's say disease. So let me say in the output let's say if the probability is between, let's say between 0.01, let's say to let's say to 0. Let's say 3, let's say right low risk, but let's say it held. Let's say if the probability is, let's say 0. Let's say 3 0 let's say 3 1, let's say to 0.5. So let's say right medium risk, let's say see a doctor. Then let's say if the probability, let's say if the probability is between, say between 0.5, let's say 5 1, let's say to 1 to 1. So let me say right high risk, let's say go to the hospital, go to the what, to the hospital. So let's just run this and see. Sorry, you need to create the click on this, the artifact. So sorry, I should have this thing. Let me just copy this. So you remember to click the, let me just start a new one. So remember to click this before you write. So I will just paste. So I will add this one from. So this one, maybe you need the basic of the programming language, maybe so that when there is a kind of an error in the coding, so maybe you can correct that. So you just need the basics, so which are not actually difficult through YouTube. Maybe if you just allocate little time, so you can be able to get that. So it has done that. So let me just try the values we used in this example, whereby we said let the H be 45 and the blood pressure be 120. So the H we set let it be what 45 and the blood pressure is what 120. Then we say this one is what, then this one is 3 and the next one is 2.5. So this is 3. So the next one is 2.5. This one we set 100. So we say calculate tricks. So you see it has set the probability is 0.219 and it is low risk. So let's see whether it is correct with this. Yeah, so you see 0.2 and the probability is 0.28 because this is the formula. The probability is 0.286, something like that. So let's maybe change the blood pressure to, let's say, 150. So the probability will now change to 0.23. So let's say we change this one to, let's say, 4. So you see the probability is this. So let's change this one blood sugar, let's say, to 180 or something like that. So the probability is 0.4. So maybe let's say this is 200, for instance. And let's say maybe the H, let's increase it to 50. So the probability is 0.5. So let me just copy this data into this thing we have used, we have developed. So I got what? I got 50, 150, and 4. So I'll write here 50, 50, then 150. So here I used 4. So what are the next variables? 2.1 and what 100. So this is 2.1 and 100. I think this is what is it 100? Okay, it's 200. So here I will change this one to what 200. So you calculate. So you see 0.5. It says high risk, go to the hospital. So you can deploy this. So once you deploy it, it will give you a kind of a link that you can share with others. And maybe let's say let's open this link in a browser so that if you share it with them, they can just put it in their browser and maybe try to open that, so it will automatically takes them to that. Okay, so let's wait for the network. So it will automatically take you to the developed calculator. So when you distribute this to them, so maybe in the primary health centers, if you can't, maybe provide a place whereby they can be having this test at a particular given time, so they can be able to monitor their risks. And once they see a kind of a red alert, so they can quickly come to the hospital for a checkup and proper guidance from the doctors and all those are concerned. So let's say the blood pressure, let's say it's 178. So let's say this level is 4, and let's say this level is what? Let's say maybe 3. So the blood sugar, let's say 160. So you can just calculate. So you see it's a medium risk and see a doctor. So something like that. Importantly, what we need to understand is that no model is 100% reliable. So that is why normally the 0.05, that is the 5%, is normally being left out. There will be a kind of a likelihood of false negative and a what false positive. But for you to reduce that, so you have to get a lot of data. So the data should be many, as many as possible. So that would also reduce that. But remember, I said this is a kind of a solution-driven research that focuses on the symptoms rather than the root cause. So maybe before the findings of those, so you can think of a way to maybe help your people and try to listen. And this is to be done by all those researchers in the field of the medical line. So these are the things that we are supposed to be doing actually. So we have to change our mindset from the conventional project report writing, end of the year project report writing, whereby we will ask the student to write on something that are not maybe solution driven. And at the end of the day, after the defense, we will just leave everything and those will take over the entire this thing. So this is just the information or the message in this particular video. So we will meet in the next video. Assalamu alaikum.